Welcome back to the Scratch tutorial series with Mr. Ezra R. In this video I'm going to be covering creating basic movement code and going over how Scratch deals with coordinates within its interface. So what we're going to be doing here is we're going to get this cat moving around the screen left, right, up, and down. Now we can click and drag him, but that's not what we want to do. We want to get keyboard inputs and we want to get Scratch sensing when we're pressing certain keys on our keyboards. The first thing I am going to do though is I am going to change the size of Scratch. It's just a little big at the moment and we won't have a lot of room to work with if he's moving around at this size. So what I'm going to do is going to go down into the Scratch palette and I'm just going to change his size to about 35, which is a little bit smaller and gives us lots of room to work with. So set his size at 35. The other thing I'm going to do is I'm going to click on the stage palette right here. And we're going to scroll down. You can see there's a little button at the bottom, turns green when you hover over it. I'm going to click on choose a backdrop. Now we can choose a backdrop paint, choose a surprise or a random one, or upload one. So if you want to create a custom backdrop, you can there, finding an image online. But I'm going to choose a backdrop from the existing library. And click on that. And we get a whole series of different backdrops. It actually shows you them all, but we can search in here. And I want you to search for grid. And we're going to select the first grid that comes up. That's the XY grid. And we're going to click on it once to select that as our backdrop. Now what the XY grid is it kind of gives you an idea of how Scratch goes about mapping coordinates within its program window. So you can see here we have a y-axis, which is our vertical axis, and we have an x-axis along the center, which is our horizontal axis. So Scratch uses a sort of a standard coordinate mapping graph with 4 quadrants, positive and negative, in order to map the coordinates of where any individual sprite happens to be at the moment or how to adjust the placement of those sprites. So you'll notice that when I click on Scratch and move him around like this, down here in the sprite library, it actually will tell me the x coordinate and the y coordinate. So you can see right now he is sitting in this bottom left-hand coordinate at negative x 103 and y negative 74. So the way the quadrants work are your positive coordinates are up in the top right-hand corner. So you can see positive x. So anything to the right of the center is going to be a positive x value. Anything to the left is going to be a negative x value. And anything on the top half of the screen is going to be a positive y value. And anything on the bottom is going to be a negative y value. So this is positive x, positive y, positive x, negative y, negative x, negative y, and negative x, positive y. Now you can see a few little numbers here on this grid as well. Right here on the edges you have x negative 240 and x 240, which means that there are 240 units of positive x and 240 units of negative x from the center, meaning that the screen width is a total of 480 units. Now as far as y goes, you have positive 180 at the top here and negative 180 at the bottom here, meaning that the total height of the screen, when you add those numbers together, is 360 units. So this is a 480 by 360 unit screen, kind of like an old low resolution monitor. Not a lot of room to work with or a lot of resolution, but it is what we're working with here with Scratch. If you have your object selected or your sprite selected, you can also just manually type these in. So if I type in 0, 0 and hit enter, you see that Scratch automatically locks itself right to the central point of the screen, which is coordinate 0, 0, right in the very, very middle of the screen. If I were to type in something like 100, 100, you can see how Scratch moves those coordinates because we are defining those as the place it should be. So let's get on to getting Scratch to move a little bit. Let's bring him back down here along this. I'm going to actually set him almost like he's standing on this little line right here, right in the middle. And with Scratch selected, we are now going to move over to the block coding screen. One really important concept to remember is that every sprite has its own block coding screen. It's almost like its own little brain or own little program that it's running. And there can be communication between sprites, but the code in here will generally refer to what this sprite itself is doing. Now, I actually would prefer if events were your first block of code. This maybe should actually sit at the top. Events tend to be what start all your code running in Scratch. So anytime you want to start a new block of code or you want to start creating something new, you always need to start with an event, which you can always tell they have this little sort of hump on the top of them, and that means that they are a code that starts other code running. Other code will not run without an event to start it, whatever that event happens to be. And there are a few different types of events here. Now, we have a couple main ones here. We often use when the green flag is clicked event, which basically means when the program starts and you click this little go flag. But at the moment, we're going to do something a little bit different. We're going to grab the when key pressed block. And you'll notice this has a little drop-down menu here, so we can actually define what key is pressed. And we're going to drag 4 of these. 4 of these here. And we're going to code in the 4 directional arrows on our keyboard. So we're going to keep these all together in a group, kind of near to each other, and we're going to do it like this. Now we could even arrange them in such a way that it kind of actually looks a little bit like our keyboard itself, if we wanted to. So we're going to do, here is our up arrow, here is our down arrow. Maybe I'll just move them a little bit more like this so we've got a bit more room. Here is our left arrow, and here is our right arrow. So they're kind of arranged like they are on our keyboard. Kind of makes visual sense. It can be helpful to kind of do that sort of a little trick when you're working in Scratch or any other program. And we're going to go to our motion blocks. And what these events are is they're going to be checking for if these keys are being pressed. So when that key is pressed, it's going to execute a command. And we are going to add in a couple blocks, a change X block and a change Y. Changing X means changing the horizontal position. So let's grab the X and let's put them on the 2 horizontal ones, right? So left and right, that's our horizontal position is left and right. And we're going to grab a change Y, and we're going to grab that and put it on our X, or sorry, our up and down keys. Now, this is really easy to figure out or make sense of if you think about this. If we have Scratch right here and he is traveling to the right, that means the X value is increasing, right? So when right arrow key is pressed, if we change the X value by 10, that means it's increasing. If we were to be going to the left, the X value would be decreasing. So it would be removing X value in order to move it to the left. So for this left arrow right here, we're going to change the X by -10 because we're going to minus 10 from the X position. It's important that you have change X and change Y, not set X and set Y. Set refers to an absolute position or absolute coordinate, whereas change refers to changing the X value from the current by this number right here. Now, same thing goes for up and down. If we are adding to the Y value, we'll be going up. That looks good already right there. And if we are removing or going down, we're going to be removing from the Y value. That's -10. Now, 10 refers to the number of units of change. So let's give this a little test by clicking the green flag. And if we use our key inputs, you can see that as we press the keys in each direction, we kind of move around. Now, it's a little bit of a chunky thing because this isn't built for continuous input. It's kind of just running it once and then checking and then running it once again, but it's good enough for now. There are smoother ways to do it, but for just a beginning tutorial, this will be good enough to get the basic concepts. Okay, so we got 4 directional movement done. We are going to leave it at that for this video, and we're going to cover a few more concepts about refining this movement in our next video.